Welcome back, everyone. We've got a truly fascinating explainer lined up for you today. Imagine taking a highly complex medical research process, something that normally takes hours, and shrinking it down to literally just a few minutes. Well, that's exactly what Google is doing right now with Gemini for Science. It's a newly announced suite of powerful AI tools, and it is making a massive leap from just predicting text to actively accelerating life-saving medical research. Let's jump right into how this technology actually works. Okay, let's dive into this. What if medical breakthroughs took minutes, not hours? The biggest bottleneck in discovering cures often isn't human brain power, right? It's simply time. The time it takes to gather, parse, and cross-reference massive amounts of data. And Google is attacking this exact bottleneck head-on with these new AI tools built specifically for the scientific and medical fields. But to truly grasp how this is going to transform medicine, we first need to look under the hood at the engine making it all possible. Enter Anti-Gravity 2.0. So this is Google's new desktop application, and it's built entirely around the concept of agentic AI. Now, the old version of anti-gravity, it looked exactly like a super complex programmer screen. We're talking dense code, intimidating terminal windows, the whole shebang. But this new version strips all of that away. The entire interface is now just this incredibly approachable chat box. It looks almost identical to something like WhatsApp. But behind that simple interface, it's running multiple AI agents in parallel. Think of these agents as a team of tireless digital researchers. They're all working on different pieces of the exact same problem simultaneously and then reporting back to you. Now, what's really interesting about this slide is how Google actually tested these autonomous agents. Before unleashing them on human biology, they threw this really fun yet surprisingly complex challenge at the AI. They typed one single sentence into the anti-gravity chat box: make a Chrome Dino Infinite Runner game that plays itself in a cyber theme. Powered by Gemini 3.5 Flash, the agent wrote out a complete development plan in, wait for it, 4 seconds. 4 seconds! It broke down the cyber-styled visuals, the dinosaur's movement, a self-playing brain, and even retro sound effects. All the user had to do was click proceed. Zero manual code was written by a human. The AI was totally in the driver's seat. But building a game from scratch usually involves a ton of trial and error, and this AI was absolutely no exception. It writes the development plan, generates the code, and tries to load the game. But boom, it hits an error. The page simply won't load. Now, instead of throwing its digital hands up and quitting, the agent acts exactly like that tireless researcher we talked about. It starts investigating and fixing the code completely autonomously. It rapidly tries different approaches, one after the other, literally at machine speed, until the game actually loads properly. Now, even when the game finally loaded, the AI player controlling the dinosaur was honestly pretty terrible. It was crashing into obstacles left and right, so the human testers stepped in with this slightly exasperated, incredibly simple prompt: this is not working, please make it work. And that was the only human intervention needed. The genuinely fascinating part here, the user didn't need to type anything highly technical, because the agent had already noticed the failures from the running game on its own. It was already in the background, autonomously fixing its obstacle detection and jumping logic. It literally taught itself to play the game perfectly without any further guidance. Okay, so we just saw how a system of parallel agents can autonomously plan, code, troubleshoot, and perfect a software program. But let's transition from video games to life sciences, right? From cyber dinosaurs to the ultimate high-stakes arena, human biology. Think about it. If an AI agent can instantly adapt to a coding failure, what happens when you point those exact same parallel processing agents at complex medical data? Well, this brings us to Google's major announcement, Gemini for Science. And this brilliantly illustrates how the whole thing comes together. It all relies on a brilliant new feature bundle called Science Skills. This Science Skills bundle serves as a high-speed bridge. It directly connects anti-gravity, that incredibly smart autonomous agent platform we just looked at, to over 30 major life science databases. So instead of an AI generating code for a game, it is now scanning, processing, and pulling factual biological data from across dozens of the most vital scientific repositories in the world, all simultaneously. Let's just take a second to really break down the paradigm shift here, the old way versus the new way. Traditionally, a scientist researching a complex biological problem, maybe a specific genetic mutation, would have to manually query multiple databases. They'd painstakingly cross-reference research papers and organize all that data themselves. It's a process that inherently takes hours of manual cross-referencing and data gathering, sometimes days or weeks. But the new way? With Science Skills, the anti-gravity agents do this in parallel. You get minutes of agentic analysis across databases simultaneously. What used to take massive amounts of manual labor is now instantly synthesized. So, the crucial point is that this isn't just theoretical. To prove the real world impact of this massive data processing system, Google's own researchers put it to the test. The target? A rare genetic disease linked to specific biological mutations. By deploying the Science Skills Bundle, the AI agents were able to instantly pull and synthesize all the relevant, highly specialized data, and they completed the entire analysis in just a matter of minutes. By drastically reducing the time spent on data gathering, scientists are now free to focus their brilliant minds entirely on finding the actual cures. Now, you might be thinking, okay, a biotech super tool this powerful has got to be locked tightly away in some top secret Google server room, right? No way. In a huge win for the developer and scientific community, Google has made this accessible right now. You can actually find this integration available to developers on GitHub today. It is out there, right now, ready to be utilized by researchers in biotech, pharma, and beyond to start accelerating their own work immediately. This explainer really proves that generative AI has officially moved far beyond just writing our emails or generating images. By combining agentic AI with highly specialized factual data, we are absolutely setting the stage for faster diagnoses and accelerated cures for diseases that have plagued humanity for generations. It leaves us with a pretty massive question. If AI agents can map a rare disease in minutes today, what will they cure tomorrow? I'd love to hear your thoughts on this, so let me know in the comments below how you think AI is going to transform the medical field. Thanks for tuning in.